let you know. See,
Okay.
basically, if you see a IP packet here, this might be the case that it is not ICMP here. It might be the FTP data here. Then we should have a TCP here, which is for the transport layer protocol, right? So we have TCP or UDP if it is the case, right? But why we are adding extra UDP, right? Here after this VXLAN. So here is the logic behind it. And I would ask for extra 10 minutes of your attention, and that is it. And you will be getting this one of the most important concept, you can say, right? Now just try to understand if we have these four routers R1, R2, R3, and R4. When I was talking about ECMP, you all know for sure that suppose we have a segment here 4.4.4.0 which is advertised here, 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 and here, and OSPF is running, and there is a PC here. So this router is going to have two routes for 4.4.4.0 via R2 and 4.4.4.0/24, of course. Let's see this via R3. And now because these are layer 3 interfaces both can be up. The packet can go from here also and here also. Suppose there are two PCs here, PC number B and PC number C. B address is maybe 4.10, C address is 4.20. And this computer A, which is having address x.x.x, wants to communicate to 4.10. The packet will be coming here at R1. R1 will see in routing table and will see that, okay, it can go to R2 and R3. On what basis it is going to decide whether it needs to go to R2 and R3? It can decide on the multiple basis, right? It can say x.x.x.x wants to communicate to 4.4.4.10. This is maybe my first packet. The second packet is coming x.x.x.x is want to communicate to 4.4.4.20, which is host number C. So basically what it can do, it can see that the source IP and destination IP is different. This is my first packet or first flow, you can say. This is my another flow, flow 1 and flow 2. What is the difference? The difference is of destination IP. And on the basis of this difference, R1 can say that because the IP address is 4.4.4.10, whatever the packet coming from x.x.x.x and wants to go to 4.4.4.10, they should be going towards R2. And for the different IP, destination IP, which is 4.4.4.20, it can go towards R3. It means that the traffic can flow. The first flow can go from this direction, and the second flow, if I can show it in the pink color or the red color, it can go in this direction, right? And we call that on what basis that it is going over the 0/1 interface or 0/2 interface. It is the process is known as hashing. The important property of hashing is if you change anything in source IP and destination IP or source MAC or destination MAC 2, it depends on what hashing algorithm you are using. Suppose you are using source IP and destination IP based hashing, it means that anything gets changed, it is going to change the exit interface. Maybe this is 0/1 interface, 0/2 interface. If this x.x.x.x wants to communicate to 4.4.4.30, maybe another host here D, it might again choose 0/1. Very, very interesting, right? This process is actually hashing. On the basis of hashing, you decide whether you want to go to 0/1 or 0/2 because both interfaces are up, right? Very, very interesting. But here is my problem in the case of VXLAN. See, this is my inner packet or inner frame. I have put the VNI, suppose this VLAN 10 is 1000. Here the VLAN 10 is 1000. The VNI number is 1000. So I have put this 1000 number also here. Now just try to understand when this message goes here, the intelligent guy, the control plane guy will inform that you are sending a message to BBBB, right? and that is behind 5.5.5.5, and that is why you are putting source as 3333 and destination as 5555. Source MAC address is going to be CCCC and destination MAC is going to be DDD, right? DDD, as simple as that. And here is my problem. Suppose I have this host A here, which is communicating to host B. Now I have another server. Say there is server C, which again wants to communicate to B. Believe me, if server C wants to communicate to B also, this guy will be saying that B is behind 55555. Doesn't matter whether the traffic is coming from server A or server C, the source IP and destination IP will be always same. Believe me. In fact, if many machines are there in just below switch 3 and many machines are there just below switch 5, all the machines are going to be having different inner packet for sure on the basis of source MAC, destination MAC, source IP, destination IP. But the outer packet, which is seen by these guys, right? It will be absolutely same. It is going to be always same. That the packet is coming from 3.3.3 going to destination 5.5.5.5. If I talk about switch 3, the next hop is always going to be DDD, right? Because it is switch 1. Very, very interesting how I am going to load balance if these parameters are not changing. One way is to look deeper inside the packet and take decision on the basis of that, but it is going to be deep packet inspection. You are going way inside the packet. You want to add something on the basis of which you can decide where the message from host C and host A. If that is the case, then basically one port is always going to be taken because source IP, destination IP is going to be same. Then only 0 slash, suppose this is 0/1, this is 0/2, only 0/1 packet interface will be using for this packet flow from here to here to here. This was never the intention. See, we have built this VXLAN so that we can use both of the links, but because hashing is not proper, we are always resulting into use only one interface. And that is why somebody brilliant suggested an idea that I am going to add a UDP header. What UDP contains? UDP is a small header, right? 8 bytes only. It contains source port and destination port. So this intelligent guy says the destination port is always going to be 4789, which is the VXLAN port. Okay. Source port can be anything. Very, very interesting, right? So if host A is starting to communicate, this guy can say that if the packet is coming from host A, right? The source port can be 1123, any number, right? If the packet is coming from host C, the source port can be 2222. Now there is something which can differentiate the packet of host A from host C. And I can do hashing on the basis of this, that if this port number is changing, I can send some message to this interface. I can send some message to this interface, some this, some here. I can utilize both of them. Really interesting. And that is why we have put UDP header here so that we can have separate or different source port. Because you all know that in case of hashing, if anything gets changed, then we can change the destination interface. As simple as that. And here we are taking hashing, or we are deciding the exact interfaces on the basis of the source port of UDP, which we can change. As simple as that. It means that we are adding UDP to hash. We are using a UDP to send some packet over 0/1, some packet over 0/2, so that we can effectively do this ECMP. As simple as that, right? I think you all agree with me now. And this is where I would like to conclude today's session. It is already 1 hour and 20 minutes. If you guys have any question in your mind, if anything come to your mind, you want to add something here, please go ahead. Mr. Supreet has a question. Mr. Supreet, please go ahead.
Hey Vishnu, thank you. So let's say, for example, I need to have communication between two different VLANs. Now, let's say, for example, I have VLAN 10 on switch 3
Mm-hmm.
and VLAN 20 on switch 5.
Okay.
The VXLAN header will still remain the same, right? So the source IP, destination IP, and the max will still remain the same.
Absolutely.
Okay, yeah, thank you. That was it. Thank you.
Yeah. If there are different VLANs also across, means VLAN 10 here, VLAN 20 here, and here VLAN 10, VLAN 20, absolutely. The source IP, destination IP is going to be the same. You cannot decide on the basis of source IP and destination IP, and that is why we have put UDP header.